Hey students, welcome back. Today we are going to talk about reaction quotient, all right? So kind of jumping right in, we've been talking about equilibrium, and now we're going to talk about reaction quotient. Reaction quotient is calculated exactly the same as K, we just might not be at equilibrium. So we're calculated the same as K, but we just might not be at equilibrium. So we can use this at any time. Really, officially, K should only be used when we're calculating, when we're at equilibrium. Q is just for all those other times. All right, so let's talk about what that means and what that can do for us. So it's what Q can do for us is it can tell us which way the reaction is going to go so it reaches K, all right, or we reach completion or the end of the reaction, if you will. But remember, it's a dynamic equilibrium, so technically there's still stuff happening. We're just talking about it not being visible changes. We wouldn't see any visible changes. So let's kind of jump in here. Now, remember, it's calculated exactly the same as K, so that'll help us understand this. So if Q is less than K, Q is less than K, that means we have too many reactants, right? Too many reactants, so it will have to shift right to get to an equilibrium. Now, real quickly, make sure we know what it means by shift right. We're going to have the reaction go towards the product, so we get more product, so we get a larger Q, right? Okay, now if Q is greater than K, that means we have too many products. All right, too many products. And so it will shift to the left to balance out. All right, we'll talk about ways we can manipulate this a little bit in a couple of videos. I think it's a couple of videos away. If Q equals K, then we are at equilibrium. And so there will be no other movement, right? We are at equilibrium, no movement. All right, even though there's still stuff happening, dynamic equilibrium, right? But we will not have any movement. We won't see any changes in concentrations. Okay? Awesome. Let's see if we can't try this in an example. All right. We're supposed to consider the reaction and its equilibrium constant at 25 degrees C. We have I2 going with Cl2 giving us 2 ICl. Our K sub P is 81.9. So our reaction mixture contains P sub I2 of 0.114, PCl2 is 0.102, and PICl is 0.355. And we're supposed to figure out if it's at equilibrium. If it's not at equilibrium, which way is it going to shift to get to equilibrium? So pretty straightforward here. Remember, Q is calculated exactly the same as K. So I'm going to start by writing my reaction quotient expression. Again, same as K. So we'll take ICl squared over I2 times our concentration of Cl2. And we're ready to just kind of plug in our numbers here. So ICl is 0.355, and that is going to be squared over 0.114 times 0.102. All right, and now we're just going to plug it in and see where we're at with Q. So 0.355 squared divided by 0.114 divided by 0.102. And we should get 10.8. All right, so we've got 10.8. That's where we're at. We're at 10.8. Q is 10.8. K is 81.9. So what do we see? Q is less than K, right? So we need it to, that's a terrible carrot. All right, I'll try that again. Yeah, maybe not. All right. So Q is less than K. Right? So we're going to shift to the right. So we're going to shift towards the products. So we could either say shift right, or we could say shift towards the products. And there we have it. That's it. See you next time.